Hello guys and welcome back to my channel. Now what is vibration? What is torsional vibration? What is relativistic vibration? What is simple vibration? Why do we study vibration? Why the study of vibration theory and aeroelasticity used? What are the different approaches and what are the industrial applications of the study of the vibration theory and analysis, or rather vibrational theory and the study of aeroelasticity, or number one is known as resonance. Guys, now if you have got the same questions, guys, then you have made a pretty good decision, a pretty good action, guys, by coming to my channel, guys. Where I'll be sharing, some of the updates and some of the information, guys, and some of the free knowledge, guys, to you in the engineering world. So, guys, our today's topic, guys, happens to be about vibration theory and aeroelasticity, on some of the learnings, about some of the concepts about resonance and degrees of freedom. So, guys, by the way, before beginning to it, if you still, have not subscribed to our channel of Master Chintamani's infographics channel, guys, of mine, then please do it. And guys, in order to start receiving those exciting updates, guys, please do click on that bell icon. And by the way, there's a link in the description below, guys, for all of our old videos about vibration theory and analysis, even the finite element analysis, even about the town planning, even about the history of Chhatrapati Shivaji Maharaj, even about the patriotic approach of Indians, and even about the gynecology. So, guys, let us deal with our today's topic of vibration theory and aeroelasticity. So, guys, in today's episode, guys, we got to provide more emphasis, guys, into that resonance. So, guys, what resonance, guys, basically means is that when the internal excitation energy, guys, equals one of the natural frequency, in a particular element, guys, then that is basically termed as a resonance. So, guys, what a resonance says is that in an element, or rather in a vibration, guys, when the internal excitation energy, guys, present in that so-called vibratory or rather vibrational motion, guys, when it's in a state of equivalence, guys, to the natural frequency of the same vibration, guys, then what that is known as, guys, basically the concept of resonance. So, guys, the internal excitation energy, when it equals the natural frequency of the system, is resonance. And, guys, when we deal about the degrees of freedom, guys, the degrees of freedom is the total number of coordinates, which basically define the degree of motion, guys, of a so-called particle or rather an element, guys. So, that is what is the degrees of freedom. So, guys, what it means is, guys, that the total number of geometrical coordinates, which are basically used, which are static variables, guys, in state space. So, which are the spatial coordinates. Spatial, meaning space, S-P-A-T-I-A-L, spatial coordinates, guys, while we deal with those spatial coordinates, guys, and the total number of those spatial coordinates, which are basically used, guys, as to how freely and so-called material or and so-called particle, guys, can move, or rather, what ability it has, guys, to move in the different directions, guys, is determined, guys, by that state space, by that so-called thing called the degrees of freedom. And I've already told you, what was resonance. And, guys, as we're gonna deal, further, in a deeper section, guys, with in a deeper sense, guys, about vibrational theory and aeroelasticity, guys, we even happen to, get down to that topic of so-called simple harmonic motion, guys. So, guys, that simple harmonic motion has got a general equation, guys, and which is represented by Y. And, guys, there happen to be multiple types of that so-called multiple types of vibrations. Vibration, as I've already told you. And, guys, there are some of the types, which I have not basically discussed with you in the previous videographs, or rather in our previous lectures and sessions. And, guys, which was basically the transient variable, the transient vibration, guys. So, guys, let us basically once again try to reclassify, guys, or revisit, guys, are some of the types, guys, about vibrations, guys. In case you want to revisit to those all things, guys, please do visit that old lecture, guys, and link, by the way, link in the you can find the link for that, guys, in the description below. And guys, then it comes about the types of vibrations, guys, then it happens to be the transient vibration, number A. Number B, torsal vibration. Number C, the transverse vibration. Number D, damped vibration. Number E, undamped vibration. Number F, free vibration. Number G, forced vibration. Number H, simple vibration. Number I, relative vibration. And number J, guys, random vibrations. And obviously, number K, longitudinal vibration. So guys, these were basically types of vibrations, guys, which we basically going to deal with, in our today's topic, guys. Now, as I've told you, multifarious times, guys, that theory of vibrations, guys, is basically absolutely essential, guys, for the study of for the analytics, guys, of the stress and strain compositions, guys, which can basically affect, or rather make in so-called material, guys, to deform and stuff, guys. Well, guys, basically, you might be thinking that vibrations, while you gotta deal with it, those vibrations, do not in fact cause any harm. But guys, in reality they do. And guys, it really, causes a lot of harm, guys, And guys, that harm is basically outlined, guys, in such a manner, guys, that while it comes about a supersonic flight, guys, in a supersonic regime, guys, let's say a supersonic aircraft, guys, and while it's bon voyage, or while it's airborne, guys, the way in which those vibrations, guys, can basically affect it is, guys, that so-called fuselage, or rather the fundamental constitution material, or the building material, with the aid of assistance of which, or which is basically used as a fundamental constituent, guys, for the purpose of construction and building of that aircraft, guys, can be shaken down and can basically even have that presence of pores in it, guys, after the so-called really hyperfine and highly rigorous and highly dangerous vibrations, guys, which basically can seriously affect that quality of that aircraft, and it seriously even affects its durability, guys, and which clearly means, guys, if and so-called softer metal, guys, or a softer element, or a softer constituent material, guys, is used, for the construction of an aircraft, guys, then it can simply, potentially damage that aircraft. And guys, the other thing, which we gotta say is that, guys, what the theory of vibrational analysis, or rather the theory of aeroelasticity, or just simply the theory of vibrations, guys, and what helps us is, guys, it helps us in building our keen sense of sagacity, guys, in order to know, guys, as to why vibrations takes place, or as rather as what are the ways, guys, with which we can actually tackle those problems, guys, that sort of that factor of that strain and stress, guys, which is caused on that fuselage of the aircraft, since we are dealing with aeronautical engineering problems. So the strain and stress factor, guys, which is basically caused on that so-called aircraft, guys, how it can potentially affect it, or how it can even potentially damage that so-called aircraft, guys, it can be very well analyzed with the aid and implementability of the vibrational theory and aeroelasticity. And the other way in which vibration theory and aeroelasticity can help us is, guys, it can help us to determine, guys, as to what sort of vibrations, guys, are known to potentially damage it, guys. Like so far, while we get to deal with the aircrafts, guys, the torsal vibrations, guys, happen to be targeted, guys, while an aircraft, is basically airborne, and which is why, guys, in order to basically eliminate those problems, guys, and what we got to deal with is, guys, that those are materials, which are basically used for the purpose of fabrication, or rather formulation, or construction, or engineering, or building, guys, an aircraft, guys, should be very well analyzed, guys, and their stress and strain compositions, or their stress and strain, their so-called capability, or rather ability to undergo that so-called strain and stress, guys, should also be studied, in a greater efficiency, guys. So, those things are seriously required, guys, in the study of aeroelasticity, and thus even in the theory of vibration, guys. And obviously, guys, vibration is basically a motion, guys, which basically happens to be a sort of a motion, which happens to repeat itself, guys, and repeat itself, guys, in equal intervals of time, and which are even known as the periodic intervals. Now, guys, that word, or rather that terminology, periodic intervals, guys, is used while we going to talk about the intervals, which happen to be equivalent in nature, guys, and the intervals, which are equal. So, guys, when it comes about equal and periodic intervals, guys, the motion, which basically, takes place, guys, is in fact, known as the vibratory, is known as the vibration. And the other thing, which we gotta say, which we gotta say is, guys, that as I've already told you about resonance, guys, but when the internal excitation energy, guys, in an element, guys, is basically in a state of equivalence, guys, to the natural frequency of the same element, guys, then that is called resonation, or rather resonance. And now, obviously, guys, the natural frequency of an element is also studied, guys. Primitively, guys, before performing the vibrational analysis of that object. And obviously, the degrees of freedom is, guys, obviously, defined by the total number of mathematical or geometrical coordinates, guys, which basically represent the ease and efficiency, or the ease and convenience, with which that so-called object, or rather that element, guys, can rotate, or rather can move freely in different directions, guys. Like most common example, guys, seems to be that so-called power crane, guys. The power crane, which is used in the world of civil engineering and infrastructure development, or infrastructure engineering, or even architecture. So, guys, the free will, guys, which that so-called the way in which that so-called crane, or rather the header of that crane, guys, which basically seems to be like an essential automaton, guys, lifting the elements, or lifting really rigorous, or rather really heavy materials and stuff, guys. The way in which it moves, and basically the degree of ease which it actually has is, guys, basically outlined by the factor of degrees of freedom. And, guys, even if you got to think about the Mars probe, the Mars probe, which was launched, guys, that so-called Mars probe, guys, the way in which, the way, or the directions, or the sides, or the zones in which, it can move and stuff, guys, geometrically, or when it comes about directional navigation, guys, that is also very well determined, guys, by the factor of degrees of freedom, guys, of that so-called Mars probe. And the other thing, which we gotta say is, guys, that obviously, there happen to be multiple sub-classifications, which we gotta deal with, guys, while we gotta study vibration theory and aeroelasticity, guys, and some of which are, guys, as I obviously told you, guys, the natural frequency, the time, the period, even the frequency, even the so-called amplitude, even degrees of freedom, even the resonance. So, guys, as I've already told you, guys, what amplitude is, guys. That amplitude is simply the measure of the fluctuation, guys, between and so-called particle, guys, from the initial mean position, guys, to the upward position, or rather the final position. The way in which it fluctuates from the downward position to the upward position, guys, is basically outlined as the amplitude, guys. And what amplitude clearly means is, guys, it's basically the mathematical difference, or rather the delta, or rather the d, guys, which is calculated, guys, in order to find the as to what is a time interval. Now, guys, that is a separate definition, which is about a time interval, as to what is the time gap, or rather what is the time sequence, which with the factor of being often, guys, which basically takes place while a so-called particle, guys, needs to in fact travel upwards, guys, at the crest, or rather from the trough to the crest, or rather from the antinode to the node. So, guys, the way in which that particle, guys, basically fluctuates from antinode to node, guys, is very well defined by amplitude. And number one, obviously, that is the displacement, guys, which takes place between a particle, from the initial mean position to the upper final position. Now, as I've already told you, guys, that is even defined by the crest and trough. And the other thing, which we gotta deal with is, guys, that there are types of vibrations, as I've already told you, guys. So, There happen to be multiple categorizations, guys, you know, in which, guys, or rather in the loop in which, guys, you know, I mean, these all classifications, guys, will fall, guys. Like basically, guys, the damped vibration and the undamped vibration, guys, and forms in one loop. But guys, when it comes about the free vibrations and the forced vibrations, guys, when it forms in another loop, falls in another loop, or rather than categorization. And when it comes about the transient vibrations and even the random vibrations, guys, you know, it even falls in another loop. And in certain cases, guys, you know, I mean, the longitudinal vibrations and the random vibrations, you know, I mean, falls in a certain loop. And when it comes about a torsional vibrations, or rather a transverse vibration, you know, it falls in another loop. And when it comes about the damped vibrations and the undamped vibrations, guys, you know, it falls in another separate loop. So, guys, you know, these were basically, you know, some of the types of the vibrations, guys. Now, not to forget the relativistic vibration, torsional vibration, the deterministic vibration, the simple vibration, the forced vibration, the free vibration, the damped vibration, the undamped vibration, and even the free vibration and the forced vibration, and even the random vibration, even the longitudinal vibration, and even the transient vibration, and even the torsional vibration. Yeah, those were the things, you know, which I basically told you. So, guys, those were, in fact, you know, the types of the vibrations, you know, which we got to deal with, you know, in the theory of vibrational analysis, or rather in the theory of aeroelasticity. And, guys, what else, you know, which we got to learn is, guys, that obviously now, you know, for your convenience, you know, this video is grouped into part A and part B. So, guys, you know, please do not forget to watch part A. So, guys, you know, like in this so-called part B, guys, and what we got to deal with is, guys, that what are the so-called applications, guys, of the vibrational analysis, or rather the vibration theory and aeroelasticity, guys. Now, guys, you know, in order to basically, you know, study aerospace engineering, or rather solve the problems of the aviation, or rather the aeronautical engineering, guys, you know, in order to basically know what, you know, what are the effects and applications, or rather the dents, you know, which are basically caused on so-called aircraft entity, or rather an aerospace entity, guys, you know, after it basically travels at the really rapid and really fast speeds, guys, you know, whether it's in this hypersonic regime or even in the supersonic regime, guys, you know. Then the types of vibrations, guys, you know, which basically, you know, affect that so-called aircraft, guys, you know, I mean, in the while it's airborne in the atmosphere, guys, you know, is very well determined, you know, with the inner systems of the vibrations, vibration theory. And which is why, guys, and fierce knowledge, guys, you know, and the theory of vibrational analysis and theory of aeroelasticity, guys, you know, is absolutely essential, guys, you know, for the study of vibrational, for the study of vibrations. And now, obviously, you know, as I've already told you, guys, you know, what resonance, or rather resonation was. Now, you know, resonance, you know, was simply, you know, the sort of the equivalence, guys, you know, between the internal excitation energy, you know, I mean, to the natural frequency of a body. So, guys, you know, when a body, you know, I mean, has its internal excitation energy, guys, you know, in equilibrium, or rather in a state of mathematical congruence, guys, you know, with its natural frequency of that system, guys, you know, then that is basically, you know, called as a resonance. And obviously, you know, degrees of freedom is basically the total number of mathematical coordinates, you know, which basically determine, or rather define, that so-called ease or convenience, you know, with the inner systems of which, you know, that probe, guys, and it can move, guys, you know, that is basically outlined by the degrees of freedom. And, guys, you know, while we got to deal with the simple harmonic motion, guys, now simple harmonic motion, guys, you know, happens to be in motion, guys, you know, which basically, you know, happens to be in equal intervals. And, guys, you know, it is seriously important, guys, you know, to study wave analysis. Now, guys, you know, a simple harmonic motion, guys, you know, is an essential categorization, you know, you know, which we got to hop on to, guys, you know, while we got to study vibrational theory and aeroelasticity. And obviously, you know, vibration, you know, was in sort of a motion, guys, you know, which basically, you know, repeats itself, guys, in equal and periodic intervals of time, or rather periodic time sequences or periodic time gaps. Now, you know, that was what, you know, which was known to be as a vibration. And, guys, you know, vibrational analysis, guys, you know, is performed, guys, you know, for the purpose of aerospace rigorous testings and stuff. So, guys, you know, the so-called subject of aerospace vibrational theory, or rather the theory of aeroelasticity, or the vibrational analysis, guys, in aerospace engineering, or rather the VTA in aerospace engineering, which happens to be in our syllabus, guys, and for the aerospace engineering module, guys, and it seems to be a highly crucial subject, guys, and one of our interests, guys, and which has aroused the interest of a lot of scientists and a lot of material development personnel, guys, in the Boeing industry and even in the Airbus company, and which is why, guys, vibration theory and analysis is absolutely required. And guys, now obviously, it deals with the relation between the stress and strain, and even between the potential energy, and it deals a lot and a great deal with displacement, and obviously the applications of the so-called vibrations in real life, which we basically see are, guys, the vibration of, and so-called vibration of the strings of a musical instrument, guys, when a musician or a singer, or rather a so-called impresario of music, guys, like performs, guys, or the same way in which I have also sang before, whatever. So, guys, the same way in which those strings of that guitar, guys, resonate, or rather, well, because of the creation of those so-called oscillations, guys, and the way in which that sound is created, guys, and there happen to be multiple beats, there happen to be multiple tunes, there happen to be multiple zones of sound, guys, those are studied essentially, guys, with the aid and assistance of the vibration theory and aeroelasticity, and obviously, those were the examples. And by the way, one common example is, guys, even if you got to deal with a sort of a motion, which happens to exhibit an element of uniformity, guys, which happens to move in an equalized intervals of equalized and periodic intervals, guys, maybe whatever, guys, even if you're talking about, a movement of that so-called Y prism, guys, Y prism, guys, while we go to perform the wave analysis, guys, the sounds which that prism makes, guys, are even studied with the assistance of vibration theory and aeroelasticity, and even the motion of that rider, guys, and the oscillations, guys, which are basically targeted onto it, guys, in the Wheatstone-Smith-and-Reich experiment, and even in the motion of in the experiment of vibration analysis, guys, which we performed back in 12th science, back in our 12th grade. Those were the essential examples, guys, of it. So when that string is vibrated, guys, that rider moves, and guys, the degree with which that rider moves, guys, basically defines as to how strong that vibration is. So those were the examples for it. And so that was up for today, guys. The all entirely comprehensive and elucidative approach, guys, to vibration theory and aeroelasticity, this so-called subject in the aerospace engineering, guys, Bachelor of Technology, BTech. So, guys, that was from my side. This was the free information and free knowledge, which I basically wish to give you. And guys, in order for me to make more videos, guys, like this, please do keep me motivated, guys, by subscribing to my channel, and please by hitting the bell icon, guys, in order to receive the greatest updates, the greatest updates ever, guys, in infographics, and even in the engineering world, and even in the world of medical science, guys, and which is going to keep me motivated and inspired, guys, for me to communicate with you, my audience, guys, with greater concepts, guys, but whatever you want, please do comment in the section below, guys, as to what all things you want, or in what all ways I should explain you more things, or as to if I missed out on anything, guys, please do comment down in the section below, and please do rate me, and please do review me, and please do give me feedback, guys, in the comments below, and please do turn on that so-called bell icon, guys, and please subscribe to my channel if you haven't. And in case if you really like it, guys, please do share, with your friends in the engineering community and stuff, and even with your Navarrato and confidant. So whatever it is, see you, Jai Hind, and bye-bye, guys, and all the best, guys. And by the way, Jai Bhavani and Jai Shivaji. Bye-bye, guys.